Hello, guys. Actually, I have, as you know, I have posted a project as a project. The project has two main parts. In the first part, you need to design and implement sequence generator, 2-bit general sequence generator. And I hope you can finish this part by next week. Second part is actually 2-bit sequence detector. So the main idea is that here we have one input, we call it S. So here S here can be 0 or 1. So if it is 0, so actually you are going to generate sequence number 0. If it is 1, actually this circuit is going to generate sequence number 1. Okay. So as you see here, this sequence is 2-bit. It's not 1-bit. Okay, it's 2-bit. That means every clock you output two bits. Okay, and then here for this one, for the detector, it actually should receive the sequence resulted from the first part. You have to input it to the sequence generator, and then the output here should tell you if this is sequence number 0, sequence number 1, or it's undetected yet. I didn't detect anything yet. So there should be 3 options. Either when you detect the sequence 0, it has to tell you sequence 0 or sequence 1, or nothing is detected. I'm gonna come to this part later, so I'm gonna make a video for this one. So let's focus only on the first part here. You can see here both of them should be connected to the same clock. Okay, so actually what you have to do here is, okay, as I'm explaining it, the project, you have 2 sequences. As I told you, the first sequence is actually binary numbers. So it's like a counter, binary counter. So as you see here, 0 and then 1, 2, 3, okay, and then 0 again, 1, 2, 3. So you go back again, 0, 1, 2, 3, and so on. This is the sequence, okay? Or it can be gray code. Remember when I told you about gray code before? So gray code, every number is different from the previous number in only 1 bit. Okay, this is how it is. So here, for example, you start from 0, 0, and then after that you change only 1 bit, so becomes 0, 1. Now we change only 1 bit, so becomes 1, 1. Okay, so we need to see this sequence this way. And then now you change only 1 bit, okay, which is this one here, and then you get this one, and then you go to 0, 0 again and repeat again. You need to repeat. Okay, so here I'm asking you to design the finite state machine to generate the 2 sequences here. I told you S is the input, and it's up to you, but I prefer to use D flip-flops. Okay, I think you have 2 chips. Sorry, yeah, you have 2 chips. As far as I remember, one chip for JK, and this is what you have used in last lab. And also we have another one. I think this one is D flip-flop, as far as I remember. I can check, but as far as anyway, regardless, it's very easy. As I told you in this lab, it's very easy to. So one part of this last lab is about, if you have JK flip-flop, how can you turn it into D flip-flop or T flip-flop? So it's not difficult to turn it from one to another. But anyway, so I like D flip-flop because maybe it's easier. But again, if you want to use something else, I'm okay. So you should, in your kit, you should have here. So here, this you should have 2 and 2. And I think you have 2 chips from here, 2 chips from here. So in total, you should have 8 flip-flops. Okay. I think that's more than what you need here. Okay. I think so. So anyway, let's start with the first one here. In the first one here, as you see, yeah, and before you think about this part, I want you to go to the example I explained in the last lecture about designing this counter this way. So here we have this is the sequence we generated here, 3 and then 1, 2, 3, 4, 5, 6, 7. You need to study this example because it's very close to what somehow it's very close to what we want to do. Okay, but there is for sure some differences. The first difference is, as you see here in this example, we have 3 bits. That means we need 3 flip-flops. But here in the sequence generator of project, you need only 2 flip-flops. So this is the first difference, which means it's easier anyway. But this is one difference. The other difference is here So here, this is one difference, which you should be 2. The other difference here, you don't have output, okay? Same thing, sorry, this is not a difference. It's the same thing here in our lab also, we don't have output, okay? Because the output, as I told you before, when I say we don't have output, I mean output computed from using combinational circuit. So you don't need it, but we have output. So like this example here, we don't have output from a combinational circuit, but it's actually the output you get it from the flip-flops themselves. So it's the same. We are going to do the same. The main difference here only in the input here. So here you don't have any input, right? Because you generate only one sequence, but in the lab you have one input, which is S. You got what I'm saying? So the first thing you have to do here, okay, first thing you have to draw the state diagram, okay, and this is actually always the first step when you design any sequential circuit. Okay, you have to start with the state diagram, and you have to be very careful here, because I can give you a simple example. When you have a programming problem, okay, the first thing you have to do like what we call a pseudocode, or you have to do a flow chart. Okay, and then once you have the flow chart, it's very easy to implement it. It's the same thing here, but our flow chart here, like, it's a state diagram. So the state diagram is actually explaining how we can solve the problem. Once you have a correct state diagram, you can just implement it easily. Okay, for sure, if the flow chart has some problem, so your program will have a problem. That's why I'm telling you, you have to make sure your state diagram is exactly doing what you have. The first thing you have to think, how many flip-flops do you need? It's very obvious in this case. We need 2 flip-flops. So here we have state 0, 0, and then we have state 1, state 2, state 2, and the state 3. Okay, I don't want to solve it, but I just want to give you a key. For example, here, if S is, yeah, we have 2 cases, like, for example, so if S is 0, okay, so there should be the sequence this way, right? So if it is 0, okay, if S is 0, it has to be this way, okay? But now, at any moment, if you change at any moment, when you change S, for example, what do you mean by at any moment? I mean, if I'm here in this state, or this state, or this state, when I am at any state, once you change S, okay, you need to switch right away to the second sequence. You got what I'm saying? The interesting part here, you can see there's some similarity for the 2 sequences. You can see here, this is the same. This is the same. Only the difference happens here in these 2 parts here. Okay, so it shouldn't be very difficult. So what you have to do here, this is when S is 0. Okay, so what if in 0, 0, and actually S is 1, right? So you go back here, if you are at 0, 0, and actually S is 1, so you're going to move from here to here. Is that okay? Yeah, so similar. So this is actually 0 or 1. So either 0 or 1, it has to come from here to here, okay? Because this transition is the same here for the 2 sequences. It's the same, right? So if you see here, just by accident, right? Or just in this problem, it's not going to happen all the way. So this transition is the same for both of them. The change will start now, okay? So after here, if you are at 0, 1, so you have to go to 1, 1 if S actually is 1. This is what I'm going to do right now. So here, if S is 0, I'm going to come here. What if S is 1? So I have to come here if S is 1. You got what I'm saying? Because this will be the next one if S is 1. Okay. For sure, no. So we need to, I already solved it, but anyway, so what happens here after when S here is 1, so after that should be 1, 0. Okay. So here, when S is 0, you're going to move here, and S is 1, you have to move it here. Okay. Again, this is the most important part, guys. You have to make sure the state diagram is correct. You have to make sure the state diagram is doing exactly what you are expecting. Once you have correct state diagram, everything else after that just straightforward. So after you do it, you can check now. Okay, so if I'm at 0, 0, so next, as I said in the lecture, these transitions happen at clock. When the clock comes, okay, so regardless you are 0 or 1, I'm going to move from here to here. Yeah, and this is exactly, yeah, so here, yeah, and this is exactly the case here. There is one part here, if it is 1, 0, I think, yeah, so this is 1, 0. So if it is x is 0, you have to go this way. Or if x is 1, you have to go this way, right? Because in case of 1, after 1, 0 should be 0, 0, as you see here. Okay. Again, I shouldn't solve it, but because this is very important part. If you make mistake here, everything after that will be wrong. And also maybe I'm gonna leave detector for you to think about it. But it's very important, guys, to understand how can you create this sequential this state diagram. Okay, so that this state diagram can do exactly what you want to do. Okay, so think about it and see if this one is generating. The way I do it here, this is how the circuit will behave. Okay, so if you are at 0, 0, okay, and then you are, regardless you are 0, 1, you are going to move from here to here when the clock comes. That's exactly what I want to do, right? If I'm 0, 1, okay, and S is 0, so I'm going to come to 1, 0. That's exactly what happens here. So 1, 0, okay. However, if S is 1, okay, so I'm going to move to 1, 1. That's exactly what I'm describing here. Okay, guys, so try to spend some time on this one, think about it very carefully. And then after that, you can just look at the examples you have in the slides. After anything after the state diagram is just straightforward. So how, number one, you have to translate the state diagram into state table. That's very easy. Once you do that, you need to implement it using digital tools, and you can test it. It's very easy, right, to test it. So we just put S is 0, put S is 0 and see if the sequence you get is as expected. Put S is 1, you can see if it is expected or not. At any moment, it change from 1 to 0 or 0 to 1, and see if the sequence will change immediately or not. It has to change from one sequence immediately. Okay, that means, for example, I can give you one example here. For example, if I'm in this state and the change happened at this state, is that okay? So here after 1, 0, so that means I have to move quickly from here to here. 1, 0 should come to 0, 0. Is that okay? Same thing if I am if the circuit is here, for example, at 1, 1 here, okay, and then and next time it has to come to here, but I change S from 0, I change it for S from 1 to 0. So actually what happened, it has to come to this state here, okay, and then go back to here. Okay, anyway, that's very interesting. So here, once you have the circuit, so you should have two flip-flops, okay, and then you should have here a combinational circuit. This combinational circuit should be function as you know, you have here A and B, or whatever you call it, A and B. Okay, so you have A and B, and you have X as well. So you have to put all possible cases, and then you need to see what is the next state, as I said in the lecture, and then you have to see what should I put here at the input here. Okay, what circuit? So you need to get as I explained in the lecture. Even you have several examples here. You need to get relation between AB and X, okay, and the input of the flip-flops here. Okay, for example, if you use D or whatever. Okay, again, I recommend to use D flip-flop, but if you want to use any other flip-flop, I'm totally fine. It's not a big deal. Okay, as long as it works, it's not a big deal. After that, I'm asking you here to draw the circuit. Okay, so this circuit should have the chips for the maybe one chip. Okay, because you need only two. You have the chips. It already has two. Okay, you need to show me the connection. Also, you need to see if we are going to using AND or depends on, I don't know what gates you are going to use here. You have to also put it in mind. You have to implement it. Also, you have to test it. Also, I want you to draw a timing diagram to show how it works given E0 or E1. So yeah, so here I'm using E0 and E1, okay? And when S equal to 0 and S equal to 1, okay? So just you need to draw the state diagram for this one. I think that's it. It's just a very easy lab. I wish you can finish. I'm not going to explain. So you can think about the second one for now, but maybe I'm going to make another video on the second one. At least for the coming week, you need to finish this one. Make sure it works. Show it to the TA, and then maybe the lab after you can move to this one. Okay, so you have until the end of the semester to finish this project. It should be easy, not difficult. Okay. Okay. Anyway, so I'm gonna make another video for the detector, but at least for the coming lab, I want to finish this one. Oh, yeah, I forgot to tell you about the clock. For the clock here, you can, the worst thing you can make a clock, but you can with high frequency. So everything will be fast. You're not going to be able to see anything because everything is, or if you want to, because you don't have too many states here and you want to see the states one by one. So either you can make the frequency of this clock very low frequency or the time high time. Okay, for example, you can use 1 hertz or so that every state is going to stay for 1 second. The other option, you can do it manually, as we did in the last lab. I'm totally fine with that. Okay, because you wanna investigate, you wanna check, you wanna analyze the circuit, so you can do it manually. So every time you enter every time you enter a clock, so actually the circuit has to move from one state to another. Okay, I think manually it's going to be better for you, especially we don't have too many states here. Yeah, manually will be so that you can observe the transition, how the transitions works or not. Okay. For sure, the timing diagram of this one is more complicated than this one. That's why I want you to start with the easy one. Try to understand it. Again, I wish you listen to me before you start this lab. Please go to the lecture, see the example. I especially the last example, I explained 2 examples on how can you create sequential diagrams. And how you start from sequential a state diagram, and then you create a sequential circuit. So you can just simply, before you start this lab, try to study this topic. It's very important topic for sure. Okay, thanks guys, bye.